we're going to grab the site model. I'm just going to pick a random site. Simona, I'll use your site. What's your number? 32. Okay. So we're going to be using a special function today that you probably haven't used before. Those of you who were in my class last semester, I've explained it to you. So I'm going to ask that you guys don't answer any of the questions that I asked today. And it's called Delaney. It involves triangulation on a cloud of points. So just anyone, could someone define what a mesh is? If you can remember back to Matt's explanation of a mesh, can someone within like 2 sentences describe what a mesh is? No? No one?
Surface made of polygons.
Pardon? A surface made of polygons. Right. Okay. So that could be quite confusing for some people, because surface means something in our world. Surface is usually talking about mathematical NURBS surfaces. So a surface made of polygons is actually like, it's two opposite things, right? Right. So could you have a mesh that has more than one object in it? So when you draw a curve and another curve in Rhino, are they the same object? No? No, they're two separate objects, right? And I can never make them the same object. They can never be the same. Like as in one contained thing. But with meshes, I can draw multiple meshes and have them exist in the same object. Okay? So just to reiterate what a mesh is a cloud of points and instructions on how to connect them. So if this is point 0, 1, 2, then we would have instructions on how to connect them to make a polygon. So you're right, there are polygons. And usually in Rhino and Grasshopper, you are limited to 3 and 4-sided polygons. But there are other meshes in the world that could have more, but we're limited to 3 or 4 sides. And so all that is a set of instructions, 2, 1, 3, 4, on how to join them, okay? So when we are working on, it was 32, right? Yeah. Sweet. So a lot of you have made a commentary on the fact that the model's heavy. And you're right, it's heavy. My Ultrabook is finding it quite hard to move around, and that's because it's an Ultrabook. So usually if I were to be working on such a heavy model, I would extract the information out. And I know I've talked to you a lot about that already, but I'm just going to go over it properly in the lecture now. So one way of doing that is just to select that information and extract it. Export it as a separate file and work on it there. Everyone's familiar with the layers panel in Rhino? Who's not? How about Sophie? You familiar with layers now?
I have checked it out.
Brilliant. Okay. So what you'll have noticed is I've actually set this file up. It has nested layers. So Rhino allows you to nest layers inside other layers. A lot of other programs don't let you do that. Okay, so just consider that. So if we were to export this to AutoCAD, AutoCAD can't understand nested layers. But what we need to do is just go through and unlock every layer. We need to make sure that we're unlocking all the layers, even if they're nested. We're going to select 32 if I can find it. There it is. Everyone's familiar with selection in Rhino? You select from left to right. It only selects what's contained inside the box, inside the window. You select right to left. It will select anything that crosses over that window and everything that's inside that window. So let me just demonstrate briefly. So if I select this way over 32, it's only selecting what's inside that window, whilst if I select from right to left, it selects anything that crosses that window as well. Cool? So now that it's selected, I can export selected. I'm just going to chuck this on my desktop, and I'm going to call this code 124032. So, who of you have actually tried to move this thing into 3D? So, if you look at this thing in top view, this is how most architects and diplomatic way of describing it, nostalgic people look at architecture. They look at it orthographically, they work on paper, they work on 2D surfaces. So, this thing, we're seeing it in 2D. If we were to actually shift it into 3D, we can see the surveyors have actually put the contours in there where they should be in 3D, whilst every other thing that's been drawn has been drawn 2D. Okay? So what's quite interesting is all we really need to do to model this site is use the contours. Cool? Now, fortunately for you guys, this is in 3D. How many surveys have you got that aren't in 3D? Countless?
I don't think I've ever received anything in 3D.
Really? So one big shit. Right. So one big problem is that you will be working with people in the future that cannot think in 3D and don't actually see this 3D model as being useful. What they do is they actually see it as being an annoyance. Okay? Because what happens is when they go to start drawing lines on it, it'll snap to the 3D points on it, and you start getting these lines that jump about. If they measure the length of those lines, it's going to be longer than what they're intending it to be in 2D.
So they panic and flatten everything.
So what they do is they grab everything and they flatten it. So for example, they would grab this whole thing, they would go project to C-plane, and they're good, right? They can now work in 2D, they don't care. If they do that to the original survey file, you're fucked, okay? Because there's no other they've affected the original file. And so that's what Julia has had to deal with in the past, where you have to effectively take these lines and move them back into 3D. Fortunately for you guys, Cox doesn't fuck up their original survey files. It's a jab at hassle. And so we can work with this. So next thing, contours. Everyone familiar with what contours are? Yes? No? Yes? Okay, so contours are what I would consider are human readable ways of communicating 3D space. As contours get closer together, you start finding steeper results. As they get further away, it gets shallower. But if you have contours that don't have numbers, ever receive them? Sometimes.
But when they send it flat, at least they have numbers.
Yeah. If they send you contours and they don't have numbers, which way is this going? We know its steepness, we know the slope, but is it going down? Are we looking at a trough, or are we looking at a hill? Do you know? Could this be this, or could it be that? You can't tell, right? So contours, and the other thing is, this particular contour drawing is showing you this. How tall is the hill? You don't know, right? You can only assume that information. That's the only information we know. Any information other than that is assumed. We don't know, right? So contours are actually the last thing you want to work with. Unfortunately, we have to work with contours here, so you guys are compromising. What you guys want to be using is spot heights. Spot heights are what are actually used to generate contours by surveyors. What we're about to do with the survey contours is the exact same process surveyors use to generate contours. So they take spot heights, they cut planes through them, just like you guys did with the waffle, yeah? And then they bake the lines out and they send them to the architect, okay? Take a note, in 3 to 5 years' time, however long it takes you to get through this and get into industry, if you have the opportunity to talk to a surveyor, you want spot heights, okay? If you have a choice between the two, spot heights, okay? Great. So, just to reiterate, what do we need to create a mesh? What defines a mesh? A cloud of points and the instructions to make them, right? So from this, if we want to make a mesh of this, what do we have to get from it? Yeah, this will take a minute. This is good. We're in time. We're good. What do we have to get from these contours to make a mesh? Just think about what makes a mesh. Now, what do we have to get from these to make that mesh? The points, right? Now, how do we get those points? I'm going to pull up Grasshopper and we're going to start our script. While this is loading, can someone think of a way that we could get points from this? Pardon? Divide them? Yeah, that's you could do that. I think dividing them might produce more points than what we need, because if you have a line like that and you start dividing it, you could end up with that as a result. Dividing can give you kinks, but do you really need that point? Are you over-generating information? So the thing here is, it depends, right? There's no correct answer. If you need more points, you need more points. But today, I don't think we need it. What we're going to do is we're going to explode the curve. Exploding the curve gives us both the line segments of those curves and the vertices that make them up. Is everyone happy with me using bifocals? Yes? No? Okay, just so you get to know me, I like you coding in Grasshopper with icons. Okay? It might not be the way that you learnt how to code with Grasshopper. I personally prefer icons. I'm a visual person. So do you. But there is a plugin out there called Bifocals, and what is actually good for you, Romany, as well. For those people who are dyslexic, icons are great, right? Because it's just like a little image, yeah? If anything, Grasshopper has made coding quite easy for those people who have that problem. Right, back to Bifocals. Bifocals is a plugin. It effectively lets me drop it, the Bifocals component in, and it then tells you the name, okay? If you want it, you just have to go to Food for Rhino and download it. But now I can teach for both those people who want to see the words and those people who want to see the icon, okay? So everyone knows where to get it. Everyone's familiar with Food for Rhino. Okay, what I'll do is I'll put a link on the wiki as well so that you can easy access to get to it. So we've exploded the curves. We have points. Now, this is where Delaney becomes important. I don't want to just teach you guys how to go get the Delaney component, stick it in, and have it work. Because I want you to understand what Delaney does. And this is where my class from last semester, you're not allowed to say anything, yeah? So, I'm going to hide everything in this model except for these points. The outcome of this thing is going to look like this. Okay, so there's our points, and we've managed to generate a 3D surface over our site, a 3D mesh over our site. What is the Delaney mesh component actually doing? If I have a collection of points, what else do I need to make that a mesh? I ask really simple questions. So if it's like, Instructions, right? So what is the Delaney mesh doing? Component doing? Making the instructions, right? So if I were to ask you to start making a mesh out of this, can you instruct me on how to do it? Another thing that my class would be used to is 2 brain cell man, right? So Grasshopper is a really dumb, fast workhorse, right? It has no idea what you want. It doesn't know how you want it. You have to instruct it in the most explicit way. And if you tell it to do something dumb, it's going to do something dumb. So Baptiste, tell me instruct me on how to join these up. And consider, if you tell me something dumb, I'll do something dumb.
Like the logic behind how learning works.
Give me instructions on how to join that up.
Start with like some random point.
Okay, what's the random point? Or do you want me to decide a random point? Okay, I've decided a random point. What's the next thing that I do?
Then find the closest point.
Right. I'm starting with 2 and finding the closest point. That's 3.
Yeah. And then find the next closest point.
2.
That hasn't been chosen of the current point.
Of the current point, 3.
Yeah.
Okay, yep.
Keep on doing that. Is that?
What? So I find the closest point to this one?
Yeah. Okay. If it so it has.
Shall we go back? So once you've got to 3, what's the next instruction? I could just close it, right?
Yeah.
Right. Okay. So now I'm back at 2. What do I do now? If I use that same process, I'm just going to sit here drawing them all at the same time, right?
Well, if it hasn't been chosen already, like find the closest point that hasn't been chosen already.
Yeah. So when you have a system like this, where points are very close to each other, whilst points are far away, It gets a lot more complicated, yeah? Plus, the way your process works, it will never generate the same result, because every time, if you start at 2 and the next time you start at 3, because you're reducing the amount of points as you keep going, it'll never be the same, right? And we want consistent results. So Delaney worked out how to do this. He's an American mathematician, I think. What he did was he did exactly what Baptiste said. You pick a point, doesn't matter which point it is, and to work out where the instructions go is you draw a circle between every point. So in points of 3, right? So you draw this circle, you draw this circle. If your circle has a point in it, then it can't be an instruction, right? So this point, and this point contain that third point, right? So you won't generate a triangle like that, yeah? Whilst these 3 points, they do not contain a point within them, and therefore it can draw a triangle, okay? This is the exact step that Voronoi takes as well. So who of you have played with Voronoi? You've played with it as well? Okay, so it's kind of like the super easy way of just getting something crazy out of Grasshopper, right? You just throw random points at it and it generates like a cool thing. Julia and I know how easy it is to generate Voronoi, which is why we're not so impressed by it. But what's impressive is knowing how it works, okay? So 2 points, you draw a line between them, and you then draw a perpendicular line at the midpoint. That defines the cell of the Voronoi. So if our other point was here, there's that midpoint perpendicular. How do you know which point to draw to? Which points are a point's neighbor? Because if you have a whole bunch of points in a cloud like this, does the Voronoi system know, how does the Voronoi system know that it can't try and create a Voronoi between these 2 points, right? All it uses is the Delaney system to find out where its neighbors are before it starts doing those cells. Yeah? Cool.
He was Russian.
He was Russian in America, but he's in America, right?
It was a mountain climber as well.
Great. That's good to know.
That's something impressive.
Yeah. I like having the assistant lecturer. It's good. So, as you can see, when we have shapes, there's the eraser. When we have shapes that are convex, Delaney works perfectly, right? When we have shapes that are concave, we get problems. Nice to see you, Alan. How did the Player Unknown's Battlegrounds game go this morning? Did you come in the top 10 at all? Yeah? Good job. When we have a convex shape, it's fine, right? Because the points on here end up making a nice edge. But the instant we have points here, the system doesn't know that you can't put a polygon in that empty space, okay? So there are ways that you can script that out. Shall we do that? Yeah? Okay. So one way of doing it is, well, like for example, this is kind of a mess. Like we don't really need to know what's actually happening up there. So we could just go through and manually delete it. But a good way of doing it is actually taking the boundary of our site, offsetting it by a few tens of meters, depends on the scale, and then just trimming that. Cool? So that's what we're going to do. By the way, I really, this should be the easiest script for you to write, 4 components, right? Yeah? Cool, sweet. So, if I show everything again, we want to grab 32. Unfortunately, we do not have a nice clean polyline, so I'm just going to draw one in. We're going to bring that into the Grasshopper script. Offset it. Lachlan, what's the difference between the 2 offsets? Pardon? These 2 offsets. Okay.
So, with one, I'm not too sure, is one more parallel and the other one's more box view?
That's kind of
We'll-
true, but you know
we'll
one
do-
is perfectly parallel and the other one is not?
It depends. If you offset a line, both will be parallel.
Oh, yeah.
We'll address that question later. I just wanted to find out that you were my random survey, Lachlan. That means later I'll have to teach the class. Huh? Okay, so how many meters do we want to offset this by? It looks like this file's in millimeters, so we're going to have to write this in mils. Shall we go 10 meters? Maximum? 20? Yeah, but it's a maximum, Julia. We can do whatever we want. Woo! Okay. So what are we seeing here? What are we seeing? Is it going the way that we want it to go? No. So what's one way of fixing that? And you guys have 20 minutes to answer that question.
Expression of the distance to times it by -x.
Yep. So we could either reverse the distance, and therefore the offset goes in the other direction. But what other way could we do that? So there's 2. Pardon? Reverse the curve, or flip it. Flip the curve. Cool. So I'm going to flip the curve because I don't want to get into maths functions at the moment. And we can now quite quickly see actually what offset we could pull off without getting mess. And so we're getting about 7 meters, which is great. Cool? Are you guys okay? You're not okay? What's okay? By the way, whenever we're doing these types of workshops, I need you guys to be vocal about when you're getting lost. Are you lost? Please, in the future, when you get lost, put your hand up straight away and say, I'm lost. So at what point did you get lost?
First start, the curve. Which curve do you select?
I drew one.
Where did you do it?
I drew it around the boundary.
No, that's like the second step or the third step.
Which step?
The first one, the curve.
This one?
Yeah.
I literally went into the Rhino model and I drew the curve.
Using a pen tool.
Pardon?
Using a pen tool.
Using the Polyline tool, Polyline,
Oh, the
I went to my site and I drew, see that boundary there?
yeah.
I drew that.
Okay, so the first
I did it so quickly you didn't see.
connected.
Pardon? I pressed C at the end, and what that does is it actually closes it for you automatically.
No, I mean you didn't connect the polyline with the curve.
I did. I did. I did. I would have had to, or otherwise Grasshopper wouldn't know to grab it. So maybe I did it a different way. What I did was I had it selected, and then I right-clicked and set one curve, and then it automatically knows which one to pick. Cool? You guys? What do I need to clarify? Where are you lost at? Have you got Delaney at least? Sure.
How precise do you like drawing of boundaries supposed to be?
Pardon?
Like how precise drawing the boundaries supposed to be?
It doesn't have to be that precise, mate. Sophie? You don't know Grasshopper? Okay. So it's something we can do within the tutorial? Sweet. Brilliant. Thank you. Okay. So, we're good? We're good to go? Everyone's good? Okay, let's do it. So, there's a few ways we can do this. We could either start putting some points in the system and projecting them up. Should we do that? Should we make it a little bit more complex than normal? Yeah? Yeah, let's do it. I'm going to do the best way instead of like semi-best way. Sweet. Okay, so if I start introducing points into the system, they should still work with the Delaney mesh. So I have an offset curve. If I exploit that, that should give me points that I could now project up onto the mesh. Okay? So the key thing here, actually, no, let's not do that. No, we're doing it the good way. We'll do it the good way. Okay, so all we need to do now is extrude our curve. And I don't really think we need this to be a variable. We can make this just a straight number, make it as tall as we can, because we just need it to intersect the mesh. So I don't know anywhere that's like 9,000 meters in the air in Australia, definitely not in Ryde. So let's go 9,000 meters. And that will definitely send our outline through the mesh. Cool? Now, we want to start finding how those two meshes interact with each other, okay? There's a few ways that we can do this. We effectively want to grab the inside mesh that's bound by this curve, by that extrusion, yeah? But there are only a few ways to actually split meshes up. So just to start finding out where you guys are at when it comes to finding things without me helping, could someone tell me how a component that you've probably never seen before, how would you split the mesh?
Is it mesh intersection?
Is it mesh intersection? Like this one? That gives you the curve of those two meshes as they intersect. Okay?
What about that one?
That one? Which one? Yep. What do you think that does?
Grabs the intersection.
No, I don't think it does that. Is it very similar to region intersection or solid intersection? Are you guys familiar with what was the Boolean lecture that Matt did? Not the one that's true false, the one about shapes. split BREP, all of those types of functions. So we can do a mesh split. We can split a mesh, but what inputs does a mesh split take? Go grab the component and whoever's first to tell me gets brownie points. What? It takes a mesh. It splits with a mesh. Okay, and what do we have? We have a mesh and a nut.
Can you convert that to a mesh though?
Negative brownie points. What do we have? A mesh and a what? Polysurface or a BREP? Yep, perfect. Good. They're all good answers. So we need to convert that to what to make this split work? Great. We can do that with mesh BREP, right? Mesh BREP will convert our extrusion to a mesh, and now we can use that to split our Delaney up. So the outcome of this is we get a nice clean mesh that is relevant to our site. We can avoid all the concave Delaney problems. Do you need me to zoom out? Is everyone good? Need me to repeat at a certain point? Maybe. Everyone familiar with list item? Yes. Okay. Now, who can tell me why I didn't have to put any inputs into list item? Say that again. It defaults at 0. If what Alan said was it defaults at 0, which is correct. Okay. So that means this middle section here was the first item in the list. Now I guarantee you, in the future, it's not going to be the first item in the list on another job. It's going to be the second one. It could be the third one. It could be the fourth. So the key thing that you guys need to understand right now is something I'm not going to be able to cover in 10 minutes. Maybe I can. Is that right now this script isn't very robust. Yeah? So some of you, it might not actually be working for some of you. Who has it working? You got it working? No. Is that a question? No. Okay. So the key thing is, if it is giving you the outline, such as this one, you just need to change the index, yeah? Now, in the future, you would have to get the script to understand which one you want. It needs to analyze which one's inside the boundary and grab that one as the index, yeah? But for now, those of you who have stuff outside, just change it the 0 to 1, change it to 2, change it to 3, change it to whatever it needs to be to get that inside surface. You cool? Can I zoom in? Here? Do you want me to do this? Hang on. A really simple script for the first intermediate class. Yeah? But the thing is, instead of us creating some wacky panelization system or a letter that's your name, like from your name, this is creating something very useful in architecture. You've now got a 3D site to work with. Yeah? 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 Cool. Okay, last thing then. I'm going to use your component that you mentioned earlier. What component? You weren't playing any games. You were sleeping, weren't you? Yeah. What we're going to do is we'll just copy this extrusion up we're going to use our base curve, the one that we used in terms of the site boundary. Yeah? So that looks like this. And we can now do a mesh intersection, which will give us the boundary in 3D. So there's our 3D boundary. And so we can work in 3D with that now instead of working in 2D. And that should be effective for you guys to start doing things like the landscaping side of things in your model. Who here wants to do something to their actual slope? Do you actually want to start removing things or adding things to your landscape? Zoom out of Grasshopper or Rhino? Who here wants to start doing things to their slope? No one? Those of you who think that architecture is just placing like hard surfaces, like floors and walls down, should be also considering, how do people get to your site? How do people get to your cinema? They have to go through somewhere, right? I would call the entryway, the mall of this university, an architectural experience. Even though, yes, it may have been done by landscape architects, it is something that architects do consider and should. Just note, if you want to start altering the landscape, all you have to do is add points to your Delaney mesh or remove points from your Delaney mesh. Right? So, if I want to stick a big fat mound right here, I'm just holding control right now that allows you to move things vertically in Rhino space. So that point there floating in space, all it has to do is move into that Delaney system and it will affect it. So if I pull this up again, I grab that point. So I right click, set one point, select that point, hold shift and pull that into the Delaney mesh. We can now start affecting the site, okay? So it's just as easy to remove points from your contours. Cool? Great. And we've done basically 1 hour lecture. Any questions before we go to tutorial?
Why is it better to work with points in a mesh rather than like patching the contour lines and using a surface?
Patching like with a surface?
Yeah.
So when you deal with surfaces, surfaces, just remember, are always four-sided, okay? So a surface has to have four sides. If you put kinks in it, sharp kinks, they are not actually, they won't be seams. They'll be smooth, right? And so if you patch this system, you need to increase the number of control lines that go through it to get a reasonable detail across the site, especially if the site has things like curbs. So some of you have a road going through your site, like James. I know James has a road going through you have a road going through your site, right? I can see the road. Like you can literally read it in the contours, right? It's existing road and they're going to put a building over it. Once it starts seeing those details, you have to amp up the control lines for it, and to the point where it will literally crash, depending on the site. So what this system does, and the thing is, the point is there, and the point is there, and the point might be there. it's not accurate. So we want to have the most accurate result when it comes to site modeling. And so when you do a Delaney mesh, it's actually just connecting dots. And so we know exactly where that point is, and we know exactly where that point is. So we might as well be modeling to where we know things are. Okay? I want you guys just outside of the class to start looking at things called point clouds, because surveyors now are giving architects point clouds instead of spot heights and contours. And instead of having a system where we need to model as accurately as we can, we're actually getting billions of points that are to the like 10 decimals accurate, and it's too heavy for our model. And so we actually have to go through a process of reducing the accuracy of the survey to be able to do the work. So what I might do, I will find some non-confidential point clouds that I have access to. I will put them up on the wiki so that you guys have access to them. I'll point you to some software so you can play with them. I just be mindful that this is the type of stuff that you will be having to deal with in the future. More surveyors are doing it because it's cheaper, and obviously, like the actual detail and information that we get from this is insane compared to the traditional way of collecting survey information. Okay? Cool. Let's go to tutorial.